Hello, so in this video we're going to talk through some unit vectors. So I've been given two vectors here. I've been given A, which is -4, 0 and 8, and I've been given B, which is 10, -1 and 5. Now first things first, I've been asked to find the unit vector which is in the same direction as A. So I'm going to call that A hat, okay? Now you notice as well that I underline my vector. The reason being is because if you see it written down in like a textbook, it's written as bold. I can't obviously write it as bold, but I still need to show it's a vector, and I do so just by underlining it. The hat on the top just means I'm looking for a unit vector. Now if you remember, the way which I calculate my unit vector is by taking the vector which is in the same direction that I want my unit vector to be in, and then just dividing by the magnitude of the vector which I'm using. Okay, so let's actually find our vector. So we've got A is equal to -4, 0 and 8. So I think first of all, I need to find the magnitude of this vector here. So remember, magnitude just means the length or the size. So I can just use the Euclidean formula, or Pythagoras' formula. So I can say -4 squared plus 0 squared plus 8 squared, all square rooted. So if I stick all that in my calculator, I'm going to get the square root of 16 plus 0 plus 64. That's going to give me 4 root 5, like so. I prefer to leave it as 4 root 5 just because it's more exact, but if you did want to leave it as 8.9, that's also fine as well. Then all I need to do to find the unit vector is basically take my original vector, which is -4, 0 and 8, and divide each of those components by the magnitude, which is 4 root 5. So in other words, I should be able to say that the first component is -4 divided by 4 root 5, that's -1 over root 5, or if you prefer, root 5 over 5, that's also fine. Next component is 0, because 0 divided by anything is still 0. And the next component is going to be 2 over root 5, or if you prefer, I can also write that as 2 root 5 over 5 as well. So that there would be the unit vector which is in the same direction as A. Now for part 2, I've been asked to find the unit vector, and I'm going to call it U as my unit vector. So my unit vector is going to be in the same direction as A plus 2b. Okay, so I'm going to take A, add on 2b, I'm going to call that vector U, then I need to find the unit vector. So first things first, let's actually find out what the vector U is. So it's just simply going to take A, which is -4, 0 and 8, and add on two lots of B, and B, you remember, was 10, -1 and 5. So okay, if I just work out what this is, -4 plus 2 times 10, well, -4 plus 20 is 16. So that's the first component. Then the next component is going to be the second component, so 0 plus 2 times -1. So 0 minus 2, that's going to give me -2. And then 8 plus 2 lots of 5, that's going to give me 18. So this is the vector A plus 2b, which I'm just denoting by U. I could, of course, let it equal any letter I like, but I'll just let it equal U. And now I want to find the unit vector in the same direction as this vector I've just found. So in order to do that, I need to first of all find the magnitude of whatever this vector is. So I'm going to take 16 squared plus -2 all squared plus 18 squared, and then square root all of that. So if I stick that in my calculator, I get 2 root 46. So 2 root 146. Okay, fine. So that's going to be the magnitude. So therefore, in order to work out what the vector is, I just take each component, so the 16, -2, 18, that's the component of my vector, and then to find the unit vector, I just basically divide by the magnitude of that vector. So 16 divided by 2 root 146, that's going to be 8 over root 146. Then I'll have -2 divided by 2 root 146, that's going to be -1 over root 146. And then 18 divided by 2 root 146 is going to be 9 over root 146. Okay, fantastic. So that there is going to be the unit vector in the same direction as U. So just remember, very, very simple idea. If I want to find a unit vector which is in the same direction of another vector, I simply take the original vector and divide each component by the magnitude of that vector. Okay?